Hello everyone. Today I will continue the last activity that I was doing. I think that's last week. If I remember correctly, I was not able to solve the problem for the atomic structure. I'm not sure if it's atomic. So the problem is that I'm trying to use this. I'm not sure if it's what it really does, but I'll try to check that one uh, today on how it really works. So the problem is that when I try to look through the multiple threads that I've created, it was not able to increment the counter. So it seems like I think there is a problem with the code because it should increment the counter at least once, but we'll see right now. And before we do that, I'll refactor first this code base because primarily this is only for recreational activities, for learning advanced technique, advanced functionalities of C. So let's go. And it's kind of a hassle to just to create this one. I don't know why I created the concurrency C program, but we will remove this one and then we will just import directly. Let's see. I can do it. Multi-thread. What? See. Non-extension. Let's see. Okay. I think it's sequential. I think all of these are void. Void. One example. That's interesting. Okay. As you can see, the counter is not incrementing. Basically here we created an atomic counter with maybe I should, since this is 5, I think this is correct. So in here, as you can see, we pass the count. Oh wait, where's the counter? I think I passed the counter here. Inner bars. Okay. I think I know now. C equals to counter. We'll figure it out. Why is it not working? It's not implementing. Or maybe okay. I have an idea. So why not after the counter C segmentation. Oh, the counter incremented, but there is a problem. A segmentation fault. There's a segmentation fault where wait, should I assign a malloc here? Let's see. Inner size or no. The problem is there is a segmentation fault. But why? I think we don't need that and this. So we were able to increment the counter. Here times I guess 6. Let's see if this will. We need debug. Okay, so this is the problem. New thread. Where's the segmented? What's happening here? We have an ID and another is 26C0. F45? Where is it? Pointer, the where is it? Where is it? Where is it? Thread 1. So why is it thread? Where did I go wrong? Or maybe is it possible that here I think it works earlier here. Zero. How about that? We will assign 0 for this, and then we will get the value. So the problem, I think the problem is this one. So we tried to access a memory. Did we try to access a location that has not been so wait. Click on pthread join. Nice join. So it's a segmentation fault. Why? So this is a pointer. Happening here. Someone has labeled something. What if I will just assign this as 0? Do not assign this pointer. Yeah. So in here, presently this. Since this is an atomic counter, then we'll pass the counter here. And no need for this. So no more segmentation fault, but it's not incrementing. So I was thinking that maybe 0, then we will put it here equals to r dot c. How about that? Build, run. Yes, but oh no. 1, 2, 3. So it works. So what happened is the last part is earlier we assigned a memory for this one based on the size of atomic int, a size of. So when we try to assign the count, I think we should pass the since this is a pointer, we should pass the address of this RC and counter. But yeah, what I improved here, I just changed the logic. So in here, why did I initialize it to? So can I just pass it here, maybe, and build, run. There, so it works. So what I did here is we remove the memory allocation for the counter, so we no longer make it as a pointer. We change it to an atomic integer, so count and assign a value of 0. And then in here, so since args is a structure, so we created a structure which includes the I, which is the thread, the pthread t. So this will return, I think, unsigned long int. So it's positive values. With long int, I think long int is long int 64-bit or 32, I'm not sure. Four bytes, so 64-bit, okay? Because 1 byte is equals to 8 bits. So I wait. 4 bytes. But we will check it later. Maybe. Okay, so I want to check the address for this one, or size of. Let's see. Size of okay. Size of inner thread or I. So if I remember correctly, so we will just pass it here. Should be %LD long decimal 0, I think. So size of inner arc. If I remember correctly, it will not sum up to. So it will not sum up. if you will sum the size of pthread I and pthread C, it will not equal to the size of inner thread arc. So I think, if I remember correctly, it's called struct padding, but we will see if inner thread arc is correct. Okay, something maybe size of, oh wait, or the referencing, so I guess we'll just pass the arcs, printf, no, should be arcs, then in here it should be arcs that see if they will total to the same. And size of arcs that C, okay, will be size of arcs that C. Then, so as you can see, the size of thread I is 8, and the size of the counter value, which is the atomic end, is 4. So 8 bytes is 8 bytes. Wait. The size of return bytes or bits. Okay, bytes. So in here, as you can see, the size of the args is 16 bytes. So 16 bytes, how many is that? 16 bytes to bits, 128 bit. And then the size of args I is 8, and the size of the args C, which is the counter, the atomic end, is 4. So as you can see, there is a missing 2. We will check this one. I think this is what we call as struct padding. C struct line private padding between members. This is done to make the program run faster because most CPU read data more efficiently when it's properly aligned in memory. So it's not a total value of 16. try this again. So if there are 4 threads, oh, as you can see, there is an index, the same value. I don't know why the index is executed twice. Sometimes it's 4, so it's not incrementing. Why? No, it's incrementing. I added it here, then oh no. Why did I do it again? Why it's a thread T? It should be like something like that. I'll try if this really works. Server. The index 4 is executed. I see. When I change the I to a type int, the total values of are okay. So how does C works? Let's check the documentation. Let's do this like this. Doesn't have a documentation here. So how does it really works? Okay. So atomic types, if I remember correctly, there is what they called as mutics. So mutics will lock down, like for example, since we are incrementing the counter here. No, so since we are incrementing the counter here, so we are incrementing the counter here. And if I remember, I think there is a mutix versus atomic. We will understand first the atomic. Types atomic operations on variables. Atomic operations are indivisible, meaning they cannot be interrupted by other threads. So why is it? So the counter, so 1 2 3 oh. It's quite odd because I was wondering that maybe I'll just make it sequential by using join. So let's see, current thread, five. Okay, as you can see, it works. If we are forcing the thread to be sequential, the counter behaves properly, but when the threads are non-sequential, it seems like some threads that are processing step those on the other threads. So as you can see, it behaves properly in a sequential approach. Atomic types. Got me. Sure. Okay. Data consistency that guarantees that variables are updated consistently across. Okay, so let's see. So if I will comment this out, so we will check how many times 1 2 3 4. It's odd because the index 4 is printed it's not twice. Yes, it's twice. Inside thread index 4 I do, it's not just 4, it messed up. And then there is a segmentation fault like that. Yep, I think non-sequential threads are quite dangerous. Avoids race condition by making operations. So basically this is just a single thread. This so before I have an idea. Before we do this, we will remove this first. return void. But I think so. We will push this first. Sign off. More time. Here I implemented the counter. Will be incremented inside the thread. So what's that? Using that. Using the atomic. It works well if we force based on the 5 loops. So the 5, the counter is incremented correctly if we have counters incremented. If we use the pthreads, to make the extension. However, when pthreads join the implemented correctly, and something weird happening. So there are two types in here. The first type is this syntax is straightforward, it's typically used for declaring variables. Okay, so yep, I think we were able to make it work. So there are two kinds of atomic int. So the primary purpose of atomic int is to prevent the race condition. So race condition happens when like two processes are trying to update the same resources. So this usually happens in, I think, in databases, or even in memory caching like Redis. For example, the first call is trying to update a cache, let's say a cache like row 1, and the second process is also updating the process row 1. Oh, let's say a process 1, a threads 1 is updating the row 1, and the thread 2 is also trying to update the row 1. What usually happens is that logically the thread 1 should update first the row 1. So once it will be completed, that's the time that thread 2 will be able to update the row 1, so that like so that we can prevent the race condition. So race condition happens when suddenly thread 2 is the first one to update the row 1, and then thread 1 suddenly, and after that the thread 1 also updated the row 1. So the only saved value on the database is the row 1, because uh, the thread 1 is the last um, activity that has happened on that. I think we can draw this one. So in short words, okay, there are tokens of atomic. So the normal one, which you are using to declare a variable. Then the second type is when using a pointer, so you need to pass the type in here inside the atomic. But considering I explained earlier, so what I mean about that is that, let's say this is thread 1 and this is thread 2. So if this is the database, so this is the database. Let's say the thread 1 executed first. So let's say so it's how let's say increment row 1, so let's say how should we say this? I see. Let's say counter, the one that we like in counter. So basically here what increment counter by 1, then thread 2 by, is this the correct example? So basically here let's say thread 1 is updating the trying to increment the counter by 1, so this would result to 2, and then the thread 2 will increment the counter to 1 also, so this will result to 3. So what I was thinking is that, let's say in a non-sequential thread, I'm not sure, okay, I understand this correctly. if non-sequential thread, I see. So one example is in a non-sequential thread. Let's say the value of counter that um, the thread 1 has is 0. So it means that once the thread has been completed, the counter should be 2. However, let's say that in a logical way, so let's say, I think, okay, I have an idea. So let's say in here counter is 1, and this is thread 2. So in here like that. So in here, so this is, so thread 2 has a counter already of by 1. So it means it's logical that the result for this one will goes to 1, then there should be 3, 2. Yep, so this will result to 2. So what happened is suddenly that thread 1, so let's say that at the same time thread 1 and thread 2 has been executed at the same time. So let's say thread 1 try to increment the counter, and thread 2 is trying to increment also the counter, but suddenly thread 2 executed first, so the values become 1. The values become 1. Okay. So what happened is that there is conflict. There is a conflict. So I think they are trying to update the same variable at the same time, so the counter will not be incremented correctly. So the best way to do this, I think, is using try to use the atomic, but it works well when you try to implement a sequential threads, but when you're doing non-sequential, it starts behaving incorrectly. Let's see, I'll check this again. Threads. Or atomic. Does it mean that the atomic fetch add will let's say will lock up that counter? I think my mistakes here is I did not pass the counter as a pointer inside these args. So yep, I think for the next video I will try to implement an atomic with a pointer type, and we will try this again if we can make it properly work on a non-sequential threads. So this is a normal. We will add some comments here. I wonder how C programmers stay sane with this universe of concurrency. But yeah, I also add some. this implemented this function implemented the sample usage of atomic type name. So the variable is pass value for the struct red part, which will be incremented inside the thread using the and that value, that incremented variable will be accessed again outside thread. And what I like is I realized earlier that we implemented incorrectly the encounter here, because I tried to do it like this earlier, size of atomic int, something like that. I think this is not the correct way to do this. You can do it like this, atomic, then int. I'm not sure if you need to assign key, something like that in here. So I'm not sure if we need to assign a malloc for this one, but this is the correct way to declare a variable for an atomic pointer. But yeah, I'll try to implement that one on the next video. But for now, I'm gonna do something first. Wait, I'll comment this one. Okay, and as you can see, when we remove or when we replace the pthread with an int data type, the size of the structure, the inner thread args, is consistent with the size of the integer I and the atomic int counter. So 4 bytes plus 4 bytes is equals to 8 bytes. Yep. So no wonder the creators of C has grayed hair, but so when I tried to make it non-sequential, the counter is not incremented properly, but I'm gonna try later an atomic pointer data type. So yeah, I think this will be all for this video. So I'll just push it first. And 4.